So yesterday we went over biology. Does everybody get that? Does everybody understand that those are the 6 R's? And I will try to make sure to get you the document that kind of outlines it for you. So yesterday we talked about biology and what is essential, the essential components. I'm not going to dive into the molecules yet, but I do want to talk about some general concepts. And one of the things that we're going to need to talk about is this idea of, somebody mentioned it yesterday, I don't remember what class, but matter. There's matter, and then there's energy. So those are two things that a lot of you have had some experience with in middle school, have you not? You've never heard of matter, have you never really studied it at all or discussed it? Let me poll you guys now, just a quick straw poll. Who here has learned about liquids, solids, and gases in middle school? Yeah, most of you. Okay, excellent. Who's worked on kinetic and potential energy in middle school? Excellent. A lot of people, not many. Who can give me a definition or at least some examples of matter? What are some examples of matter? Yeah. All right, this table is a good example. Is there what is it about matter? What would define that table? Let's go ahead and look at that table. What makes that table matter? And okay, it's a solid, but matter can be liquid or gas too, right? But there is a solid. You're right. But what does it make? What makes it matter? What makes matter matter? Yeah. Okay, so it has mass. One more thing. Takes up space. That's right. So matter is anything that has mass and takes up space. Anything that takes up space and does liquid take up space? Does a gas take up space? Sometimes we don't think of gases as being matter, do we? Because we don't really see them often. But if you fill up a balloon, it's taking up space, isn't it? Because the inside of that balloon is filled with gas. When you breathe in, why does your chest pop up? Because the gases are filling on your lungs, and the gas is taking up space. So it does take up space. So gases, and that's a good point. It comes in different forms. It's solid, liquid, gas. There's another one that I'm going to say because you all have some of you have TVs with it, and this other one called plasma. All right. There's another one, but it's not really very useful for us here on planet Earth. There's one that's called neutron star material. It's just all made of solid neutron. It's very, very dense. A little ball of neutron star would weigh more than planet Earth. That's how dense it is. All right. So that's matter and the forms of matter. So everybody remembers that? Anybody not ever hear that before? It's okay if you haven't heard of it before. I just need to know if I need to spend a little more time on developing that. But if we've all heard it, we can go. What about energy? What do you know about energy? It comes different forms, yeah. Does it take up space? No. Does it have mass? No. So that we know. Anything else we know about energy?
Isn't it like used to power something?
Okay, well, what do you mean by power? You're right. Energy. It's a hard one, isn't it? It's not easy. I'm going to tell you what. You go to Case Western Reserve. Some really bright young people went to Case, right? Go to Case Western and randomly ask people, what is energy? I would bet you that you'd get a bunch of wrong answers. And I would bet you that you'd get a lot of different answers. For sure, you get a lot of different answers. You know why? It's hard to describe. You can't see it. You can see matter, solid, liquid, and gas. You deal with it every day. But when I tell you get an energy bar and an energy drink, you don't really understand what that means, do you? You just know it gives you energy. What does it give you energy? You think it gives you power. But what does that really mean? Yeah. Yeah, I thought you had your hand up.
So it makes things go.
Makes things go. That's exactly right. That's the thing nobody ever thinks about. Energy is the stuff of movement. It is the stuff of movement. It allows things to move. Without energy, nothing moves. Now you might think plants don't need energy, but plants do a lot of moving. They just don't move around. They move liquids and gases in and out of their cells. They're constantly growing, expanding, making new things. So energy, in order to make something, you got to move some molecules around. You have to move some atoms around. That takes what? Energy. So energy is the stuff of movement. So when we think of movement, we think about walking or running. That is true. When you have low energy, you're not moving around a lot. And what do the energy drinks help you do? Move. And by the way, when you're thinking, what are you doing? You're using energy because you're moving. You're not moving physically with your muscles. You're moving nerves are moving material up and down axons. You're releasing neurotransmitters. You're making new neurotransmitters. So this is all happening in your brain. So that really wipes you out. You're using a lot of energy to think. Thinking takes a lot of energy. So the stuff of movement. What forms? Somebody said there's different forms. What forms are there? All right, that's a good one. Thermal. And the thermal is also known as heat. Heat, unfortunately, is wasted a lot. Heat is, in general, is lost energy, but all right. So there's magnetic. I'm going to add a word to that. Or a prefix to that. Electromagnetic energy. That's this stuff right here, the stuff that runs our lights. It's electromagnetic energy. Anything else? Yeah. Kinetic energy is a big, broader term. So all of these can either be kinetic energy. There are only two general types of energy, either kinetic, which is the stuff of movement, or potential energy, which is the stuff that it's stored energy. So potential energy is stored energy, where kinetic energy is the actual movement material. But potential energy just means you have the potential to move. All right, there's different forms as well. We got nuclear, you got chemical. We're going to be focused on the chemical energy and the thermal energy in this class. We're not going to really talk too much about electromagnetic or nuclear energy. we are going to talk about thermal energy in general, but we're especially going to spend a lot of time on chemical energy. So there's going to be a lot of material on chemical energy. All right, so I'd like you to take a minute and in your groups, to people to the right or to the left of you, I'd like you to first come up with ways of reducing this here with either a question, one or two questions, or some kind of like key words that are going to, the easiest thing to do is to write stuff of something like, I'm gonna steal an easy one from you. What is energy? All right, that I just stole that from you. But at least come up with one or two more in this area, and then come up with a summary. I'll give you guys 10 minutes while I take attendance for you to come up with a summary, and I'll pause the video here. Okay, we've taken attendance, and now we're all back together, and you guys had opportunity. You're kind of quiet, some of you, but that's fine. It's going to take time for you to get used to each other. So what is it that we have as a summary? Yeah.
Are you want my summary or my little question?
Whatever you want. Let's go with a question. Whatever you got.
So the question I have was, what connection is thermal and chemical energy?
I love that question. All right. What else? Yeah.
What does energy have to do with movement?
All right. Yeah.
Where does energy come from?
Yeah.
I thought matter can be anything visible.
What is it?
Matter can be anything visible.
Anything livable?
Visible.
Visible. All right. Is that your summary, or is that like part of the?
It's like a statement.
It's a statement. Where would I guess over here. I have a problem with that. Yeah, go ahead. Here's a question for you. I'm gonna throw it back at you. Is light visible? Is light visible?
Yes.
Is light matter? Yes or no? It's not. Somebody open the door. Can I use this as an example? Would you mind if I use this interaction as an example? You're okay with it? All right. So this is exactly what I'm talking about when I'm talking about reflection and having your teacher and your colleagues help you with this reflection. Someone made a statement that said matter is anything visible. That's what we talked about this. They got this out of that, which is reasonable, right? Because we talked about things that take up space and have mass, and you think that there's something that's visible, right? That in your mind, you interpret it that way. And if she went home and she studied that, and she came in and took the test, she could get a wrong answer because she studied this really hard. She understood it. She knew that was true. But then because she reflected, because she spoke up and made the statement and then listened to her colleagues, she knows that this is actually not true. because there are many visible things that are not matter, and there are forms of matter that are invisible. For instance, air is not visible, is it? But it is matter. It has mass and it takes up space. So this is not a true statement. So we can go ahead and erase that. So while now we're revising our notes. So we see already we're doing 2 of the R's right away. So excellent example. I love it when we get something, we say something or do something that's not right, because it's an opportunity for us to learn. We've reached our boundaries of our present knowledge. Does anybody have a summary? No summary? Yeah.
My summary, I said, basically energy is a different type of matter that comes in four forms, and also energy is the reason that objects and things change.
I'm going to change your summary a little bit. Is that okay? Energy is closely related to matter. I love your statement, but I just think it makes it a little more accurate if I say closely related rather than another form of. Energy is closely related to matter. And what was the rest of that?
That comes in four different forms. Also, energy is the reason objects and things move.
I'm going to say that comes in different forms. And what's the last of it?
The reason that objects and things move, or just objects.
Is the cause. I'm going to change that a little bit too, if that's okay. You're right. I just want to tweak it. Is that all right?
Yeah.
So different forms, and allows matter to move. And there it is. That is now the only one of the 6 R's that you would have to use is recite. If you recited this information on this screen and we had a test on this, you would get anything on here correct. Because now we are sure that the information is correct because we have reflected with each other and with an instructor, and we've clarified any misunderstandings, and we've recorded, we've revised, we've reviewed to some extent, we've reduced, and we've reflected, and now we just have to recite, and we're going to get 100% or close to it, probably. We can still mess up, but that's test-taking skills at that point. Well, let's go on and build on that, because I'm really excited. You guys got to the heart of the matter. You guys really got to the essence of energy. In fact, you ever heard of this guy named Einstein? Well, she just encapsulated all his research. You just stated everything it took him years to build on. You discovered his idea without even knowing. And his idea, and I'm sure you've heard of it, is this. You literally just stated what he said, the energy and matter. The energy is just another form of matter. But it's not really, but so what Einstein said was that you can change matter and energy are interchangeable. You can take matter and turn it into energy, and take energy and turn it into matter. You just have to get it past the speed of light, which in the physical universe, as far as we know, is impossible. But we can turn at least some. We can use this equation and use this knowledge to our benefit. Not me, humans. I'm not a physicist, so don't ask me how to do that. All right. So when we look at when we look at energy, so another great question someone asked, so I'm just going to put energy and matter are interchangeable. All right, interchangeable means you can switch them. You can switch them out, but it takes a lot to do that. All right, so are you? Do you have a? Are you late? All right, okay. Before you leave, let me know your name so I can mark you here. Oh, you wrote it? Okay, great. Excellent. Thank you for that. So I recorded this so you can watch it tonight if you want to catch up on the material. So energy and matter are interchangeable. That's essential. So it was a really great question, and Solomon said, I think it was Solomon, forgive me if I'm wrong, but he asked the question, where did energy come from? Is that right, Solomon? And it really is an essential question. So we're going to go ahead and talk about this thing real quick. It's going to be a quick discussion. Really, I'm sure you've heard of it. Yeah, that's a show, but yeah. Big Bang Theory is a theory that explains some observations we made of the universe. And it turns out that this is the beginning of time. The very beginning. Before that, everything you see, all the galaxies, all the planets, all the stars, everything we're made of, all the energy and matter in the universe was in a single point. Something happened. We don't know what it is. But something happened and an explosion occurred. And in every direction, that single point, all the stuff of the universe spread out and is still spreading out to this day. And it's actually speeding up as far as we can tell. That's not bad or good, it's just a fact. You don't have to worry about it. We're talking, this stuff is about, you got maybe, if you guys in your generation may have 200-300 years of life because of new technologies coming out, your lives might be much longer than mine. But even 200-300 years, we're talking billions of years. So no matter how long you live, this is beyond our scale. Remember yesterday we talked about scale? This is beyond our scale. So we don't have to worry about these things. But you should know that's where energy came from that Big Bang. Quickly, energy and matter started interchanging. Matter and the sun started turning into energy, sunlight and heat, and started getting released. That energy is absorbed by other materials, and things get warm, and that energy then is turned into matter. In fact, you can take something called let's just go on. So from this Big Bang, through something called gravity, one of the four big forces of the universe, we formed a sun. And the sun has a big impact on any solar system because it is, in our solar system, it is the source of energy for planet Earth. The main source of energy for planet Earth is the sun for life. Main source of energy for life on Earth. So, in part because of what Einstein was talking about, that energy and matter are interchangeable, there are creatures on planet Earth that can take that energy and turn it into matter. Can you do that? Can you take energy and turn it into matter? Anybody in the room? Can anybody do that? You can? How do you do it? Think it's okay if you're wrong. Remember, being wrong is good. It just shows you, it allows you to reflect and improve. Yeah.
When you rub your hands together, you create heat.
That's good. That's a really good example of someone thinking they can create energy. And that really is an essential question. It's actually one of my favorite laws of the universe, that it's not possible to create. We can't create nothing. Nothing can create energy. Nothing. After the Big Bang, all the energy that ever was is here. We can't create it. All the matter that ever was is here. This is all we got. So we can't create it. All we can do is change it. We can change all the energy that you see when you rub your hands together, which is the example this young lady gave. You rub your hands together, you produce heat. Yes, your heat is being made, but what you're doing is taking mechanical energy and turning it into thermal energy. You're exchanging it, and you're losing a lot of that, and a lot of that energy is lost to the environment. So that all you're doing is changing. All we do is change energy from one form to the other, to the other, to the other, back and forth, and we often lose most of it. In fact, we lose 90% of the energy is lost. We can only play around with 10%. Only get 10%. Well, how much time we got left? Is it over? Class over? Well, great lesson. I hope you guys got something. Did everybody get something out of it today? All right.